watching. Today I'm working more on my stock market project. I've made some really good progress in the last few weeks. So let me go over that really quick to show you where I'm at. I work on this every day, so if you're interested in quantitative models for the stock market, markets in general, Python coding, AI tools for the coding, be sure to subscribe and follow along as I work on this every day. So I have two goals for this project. The first goal is to beat the S&P 500 by a significant margin and make money in all regimes. So basically, if we're in a recession, which it looks like we're headed into, I want to still be making money. If the S&P is going up, I want to beat it not just by a little bit, but by a significant margin, maybe double or triple the S&P. Now, the second thing I'm doing is I'm writing all of this code in Python. I'm writing it not just for me, I'm generalizing it so that anyone can use it. So if you're interested in this, check out the GitHub link in the description. But this is the second goal for the project. The key requirement I have of the second goal is everything should be free. So when I find things that could help me, do coding or stuff, I am not interested if they make me pay. And so this is going to be a nice, code base that it currently is. You can do these first two steps, which I'll go over in a second here. Create a stock universe from data. You can get the data onto your computer from the free data source I'm using. The link's in the description. Also, if you go to the GitHub, I give instructions and I have installation scripts for setting up your data. So this is the general outline of the model. Oh, and you can do all of this in under 50 lines of code, which is nice. You don't need to, write file after file like I am. You just need to download the tool and run 50 lines. So the first thing is isolating a stock universe from the data. So you don't want to use all data that's available. If you're training something to work on common stocks, you want stocks that have fundamental reports, which means that you're going to be excluding things like ETFs. You want to exclude things like test tickers as well, because those are just constant and you can't buy them. You want to exclude like weird financial instruments like 3 times SPY bull. And you want to exclude things like penny stocks because that's going to make the model perform worse. And you want to exclude low volume stocks because if you ever look at those are like kind of weird moving, and there's a lot of slippage on those. And if your model's successful and you start making a lot of money and investing a lot of money, something that's trained on high or on low volume stocks isn't very well regarded because you can't, the liquidity isn't there. You can't buy and sell easily without a lot of slippage. So once I have a model, I want to create a returns model on it. So that's predicting something to do with the returns, either the returns for the day, returns 5 days out, returns relative to the market, probability of a positive return, things like that. Once I have a really good model going, so I have some metrics to define whether the model's good or not that I'll go over in a second here. Then I'm going to plug that into a portfolio level model, which is going to decide how to allocate real money based on the output of this model. So that's what I'm working on. I started this at the beginning of the year. This is where I was at in January. So I had a model going, built a light gradient boosting method. I'm still using this model. It works really well for stock data, handles a lot of data really well. It handles a lot of features really well, which is something that you want to use for stock data, both of those. It handles missing values well, which is common in stock data sets. And it handles time series predictions really well, which of course we're doing. So the best I was able to achieve here, this is where I got at the end of January. The best model I had was 51.5% directionally accurate. That was the metric I was using at the time. It turns out this isn't the best metric to use, but I'll get to that in a second. I implemented some portfolio strategies, and if you look here, I show Sharpe ratio versus number of positions. You want a Sharpe ratio above 1, and that's like kind of the minimum requirement for implementing a model. And so you see here, the only strategy that returned a Sharpe ratio above 1 is if I'm picking one stock per day. I also looked at a slightly different model where I'm looking at probabilities, and I tried thresholding it. And this gave a nice increase to the Sharpe ratio, all the way up to 2.5, above 2.5 if I did the threshold at 54%. But this is right at the edge of the prediction. So if I chose a threshold of 55% instead, um, it wasn't making any picks. So for that reason, and for the reason that it's only picking one stock per day, I determined this is a really fragile model that I can't implement. So the next thing I had to do is, if your model's not great, there's only so much you can do at the portfolio level. You really need a good model. That's kind of the core to it. So I needed to iterate through a bunch of different targets and features. So I had to clean up the code base before I could do that, because I was using a new script every time I wanted to change the universe, model, or portfolio. So I cleaned everything up, made it really concise, flexible, and from this point, I was able to basically add anything else that I wanted. And so what really took most of the time was implementing features and targets. So these are all the features I have in my model. That you can easily you can put in any of these features into your model with just one line of code on GitHub, and they're really flexibly defined, and also they're defined so that I can add any new features with ease. Um, so once I had all of this, I wanted to look through, let's just add all features to the model and see what's important. You could see here directional accuracy, it's actually performing worse, but that doesn't matter so much. I'll get to that in a second. Yeah, so you don't want to look at directional accuracy to assess your model. More important are these values. Actually, I'll show a different slide. These values here. So I'm looking at the information coefficient. That's basically telling you the predictive power of the model. I'm shooting for 0.01 to 0.02 at least. The standard deviation of the information coefficient, which should be 3 to 13 times the information coefficient. Daily information coefficient to information ratio should be 0.02 to 0.03. On an annual basis, it should be above 0.3. And T statistic should be above 1.96. And so I found a really good model a few weeks ago here. And you can see here that it's beating all of those thresholds that I gave. It's beating all of those for every metric. You can also look at the decile analysis here. This is an indicator of how good your model is. It should look roughly like a staircase. So if you start at the bottom 10%, walk all the way up to the top 10%, it should be improving at every step. Now, this isn't a perfect staircase, but qualitatively, it's definitely giving us the shape we want. And then about a week and a half ago, I ran into a roadblock. So I was testing this model every which way that I could think of to test it. And once I had implemented catches for everything that could be going wrong with it and every single test I could want to do for it, it actually turned out that it was performing even better. So this was a really good indicator. The problem is that when I split the data differently, suddenly it fell off for all metrics and it wasn't hitting any of the metrics that I wanted. So I needed to look more into this. So I did a walk forward analysis. And this is basically looking at I grouped the data into 6-year groups. Did the first 4 years of the training years, the 5th year's validation year, which tunes the hyperparameters for the model, high level parameters that control how the model works, and then the last year is the test year. So since it was 6-year groups with the last year as the test year, my data starts in 2011. The first year was 2016, and you see all of these are showing the same general theme, which is that performance is really good until 2021 when it falls off. So I needed to look into why this is. I tried adding sectors, that didn't improve anything. I tried changing the universe, that didn't improve anything. Tried feature reduction, that didn't improve anything. And so I was really stuck. But this weekend, I think it was Saturday, I made some really good improvements. So yeah, this was kind of a big question. Look how bad this is compared to the one that I just showed. So the question is why. And I'm trimming. It turned out I was including way too many tickers in my universe, which was giving me performance which was too good, but still I was confused that it was degrading that much. And so just a sec, let me find, where did I, yeah, so here I found, uh so I said earlier the adding sectors didn't improve anything, and that was really a big question. I was like, why is this not improving anything? Well, it turns out when I tested that, I was neutralizing all features to the sector, and you don't want to do that. You just want to neutralize mean reversion and volatility features to the sector, because those are sector dependent. Other features aren't sector dependent. So, um, momentum relative to the sector, you'd rather look at momentum relative to the market because that includes sector information in it. If you're normalizing all the features to the sector, you're dropping out information basically of which sector's outperforming others, and that's not good. So here I got really good results. I did the same features as that earlier model, but then I added in what did I add in? I added in new features for all mean reversion and volatility features. I added in new ones that are not only normalized to the market, I also normalized them to the sector. So that gave me much better results. The results for the walk forward analysis though still wasn't good. And then last night, I looked at, okay, what if I add NAICS sectors? So these are basically the sectors I had were from the SEC, and these are outdated. They're sectors from 1930, so almost 100 years ago. Much more recent, you have the NAICS database. NAICS is North American Industrial Classification System. And so if I mapped my SIC codes from the SEC sectors onto the NAICS sectors, I saw that I got really good performance. So here's with the SEC neutralization using SIC codes. You can see this still looks really not at all like a nice staircase. But then you see here on the NAICS neutralization, it's performing really well. And actually, if you look at the metrics here, it's beating every metric except the T statistic. So I thought this is a really good model. Let's go forward with this. After the stream, I did a walk forward analysis because that takes quite some time to run. And here are the results. So these are not the results I was hoping for. You see information coefficient goes negative. That should never happen. So I'm going to look into this today to see if I can troubleshoot it. Hey, Furpo and Youssef, how are you guys? Oh, and by the way, subscribe and like the stream if you think this is interesting. Okay, so what I really need to look into is this. So the first thing that I notice is obviously information coefficient is negative for some years. It seems like 2020 is throwing off this information coefficient. It's also kind of curious. I don't have any years from 2021 through 2025. So the question is, why is that? The first thing I could do is look at, so do we have any data for those years? So let's go look at the data. Import pandas as PD. Now we could say df is equal to pd.read feather. And this is universe 7, so I'm going to go to /data/universes/7.feather. It's not, universes, plural, is what I want. Okay, let's look at df. And then we'll do df.date.max. Let's do df where df.date is greater than 2025-01-01 000000. So we do have data. We have 491,000 data points. So the question is, why is the walk forward analysis failing? So it fails after 2020. So do we have any data for 21? So let's do that as our first condition. Then let's add a second condition. And this guy, df.date is, oh, okay, so let's say less than, let's say 2023, 2022. Get rid of that, make it a less than, and df.date is greater than 2021 -01 -01 000000. So we do have data for 21. Let me pull up Claude on the internet. So now I want to say I ran a walk forward analysis. I have a university project I work on, and it's about a spending management platform. In the report page, I want to add AI, something like analysis. Do you have an idea on how to add AI in a platform? No, I don't, but I know that they have APIs for, like, you could use a ChatGPT API in Python. So I think, I don't know, that's something you could do. I ran a walk forward analysis on my model, which is performing successfully. Here is the, I attached the code which performs the walk forward analysis, and I pasted the script I'm using for my model. I also attached the code for generating features and the code which generates the model. My questions are these. 1. Why does the model return negative in some years? When I run model 18, also included at bottom, I beat my goal metrics. I beat my goals for every metric. Goal values for every metric. But when I run this model, it performs very poorly for some years. My second question is, why does the walk forward stop after 2020? All right, now let's give it the code. So we need to give it, for you, I guess I don't, do I really need to give it my code? I could just use the desktop app. Any further than this, I don't want to apply. The model is model 18 in model explorer.py. The walk forward is performed in test model 18 walk forward. .py. What is the walk forward? All right, now we'll say here I attached screenshots of the performance of model 18 and the walk forward. Okay, then let's give it the model 18 results. Trust. All right. Let's see if it can help. It's too hot in here. Need to take off my sweatshirt. Oh, Ophelia, you've been on my mind since the flood. All right, so this is taking a while. I guess I need to think. So what else do I want to do? What else could I work on? Oh, implement fundamental data. But I think I wrote code for that. So feature pipeline, fundamental engine. Oh, Ophelia. So then let's go back to the, where did the internet go? Why does it want access to data from other apps? No. That's so suspicious. Model Explorer. I don't get what it's doing. Model Explorer. All right, let's give it universe 7. Man, it's already 10:30 p.m. All right, let's look up the key models we want. Risk parity approach, integrating machine learning. Where the fuck does it get to the models? Why would you use LLMs? Sounds really stupid. Alright, finally we get some output. Now I have a complete picture. Great, I have the full diagnosis. Why does the walk forward return negative in some years? You're comparing two fundamentally different evaluations. Short training windows. So wait, what? Why does the walk? Oh, okay. Each fold only trains on 4 years. The standalone model trains on 9 plus. Fold 3, testing 2018, only saw 2013 to 2017, an almost interrupted bull market. Has never seen a sell off in training. Your sector and market neutralized volatility mean reversion features behave differently in a bear regime than anything the model has learned. Regime mismatch. Q4 2018 was a sharp minus 20% sell off, and 2019 was a strong momentum recovery. These are regimes and short training windows that didn't adequately capture. Cross-sectional patterns, what your CSZ score features capture. Standalone model was tested on an easy regime. Walk forward is the correct number to trust. The negative years are real risk. In live trading, your model would have lost money in 2018 and 2019. The average across all 5. This is a stale feather file problem. Test start must be true for the loop to stop. Furthermore, I have associate model 18. Furthermore, I have inspected the file myself and I've inspected the file myself and it works well. Ultra thinking first principles. Okay, let's paste that. This is a beautifully structured code base. Oh wow, thank you. Because your fundamental request class elegantly defaults to naming features with the F prefix, your existing model logic will automatically recognize them as features. To implement this with maximum elegance, we just need to update generate targets and features to route the requests to their respective engines. Okay. So fundamental engine. Why is this still thinking? It's taking forever to think. Good, it figured out the problem. If there are no fundamental features, if there is no, oh yeah, if there are no fundamental features, this guy's still thinking. Been thinking for 5.5 minutes. Okay. So we want to add fundamental features. Okay, so let's make these changes. And then in Model Explorer, we'll make a new model. Hey, Kartikana. Yeah, let me add in this function real quick and I'll go over it. All right, so here's what I'm up to. These are the kind of, I've been working on this project since the beginning of the year. These are my two goals. Number one, I want to beat the S&P 500 by a significant margin and make money in all regimes. So if the market's going up, I want to be beating the hell of the S&P 500. But if the market's going down, like it is currently, and if we're in a recession, which it looks like we're going to be going into, the model should still be giving me good returns. The second thing I want to do is so I'm writing all of this in Python, and I'm making a general version of this. I'm generalizing all of the code so that anyone can create advanced models for themselves. And I have this in GitHub. So right now you can basically make you have data. So you start with data. You want to isolate a stock universe from the data because if you use everything in the data, it's not going to work well. There's things like test stickers in the data, which are going to throw you off. Those never change in price. You also want to exclude things like penny stocks, ETFs, because those have different dynamics to the prices. And you want to exclude low volume stocks because that's not going to be tradable if you get a lot of money. So once I have a good stock universe, I'm using this to train the returns model. This is predicting things like returns for the day, returns for the next 5 days, probability of a positive return, returns relative to the market, things like that. Once I have a really good returns model, I'm going to create a portfolio model, which basically tells you it's optimized to take the input of the returns model and then position it in a portfolio with real money. So this is where I was at the end of January. I had a model. I'm using a light gradient boosting method. And I found some portfolio strategies which worked, but it was fragile for two reasons. First reason is that the only strategy that was returning a Sharpe ratio above 1 was if I picked one stock per day. Sharpe ratio of above 1 is basically the minimum threshold you need for the model to be usable. So I'm only picking one stock per day, and then I tried thresholding it. And if I put the threshold at 54%, I got a really good Sharpe ratio. But if I increase it one more percentage point to 55%, it wasn't picking any stocks. And the problem was really the portfolio method. There's only so much you can do at the portfolio level if your base model isn't good. So I needed to improve the base model. I wanted to iterate through and run as many features and targets as I could. So I had to clean up the code to do that. This is kind of overview. At the right is what the code base currently looks like. These are all the features and targets that I implemented. I found a really good model. Where is that? I found a really good model here. Oh gosh, here. But then when I did a walk forward analysis of that, you see that the model performance is basically falling off over time, so I need a better model. I found that sector features improved the model, and I found that if I'm using NAICS, the North American Industrial Classification System, I'm getting much better performance, and this is actually hitting all of my goal metrics for the model. But when I did a walk forward on this, this wasn't good and it returned negative for some years, which you see here. So I need to basically, right now I'm working on getting a better model. And so today I'm looking into why did this fail? What can I do to improve it? What are the core reasons for why it failed? And the other thing I'm working on is implementing fundamental features into the model. So I already wrote code for a lot of fundamental features. I need to go ahead and finish incorporating them into the model, which was what I was working on when that's what I'm working on right now. But let's see if Claude gave any output. Yeah. So here I'm looking into the core reasons for why it failed on the walk forward. Okay, so now it's reassessing. Too many features. I'm incorporating fundamental data right now. So I have the data, I've written the code. I did this a few weeks ago for incorporating fundamental features. I need to make this better so that I could normalize to the market and the sector. But I have the core fundamental features here. But I need to add some normalization methods. But right now I'm just using OHLCV data. And thanks for calling me smart. That's always nice to hear. Good boost to keep me motivated. My background's in physics, so it helps. All you do in physics is basically make models. Physics is just models and assessing models, but it's with reality. But you're doing like physical tests. You're not testing on, but it's all the same shit. It's just data from reality versus models. Um, so yeah, I need to update this to basically make the fundamental engine better. But now I'm trying to figure out, why does the walk forward fail? CSV persists on. My dog's having dreams. Persists on disk from whichever run last wrote it. If a previous run completed when 7.feather only had data through 2020, it wrote a 5-fold CSV. Okay, so which one? Maybe, I don't think that's the case, but let's see. What's it saying? If walk forward metrics.csv is older than 7.feather. So get info. So this is from March 29th at 10:39 p.m. It was initially written. March 29th, 10:39 p.m. Universes. Yeah. So the universe is newer than the feather. So I have two problems here. The first is that I'm getting negative returns. But the second problem is that it's ending in 2020. So I want it to go through to 2025. Yeah, so I need to figure out that. So instead of troubleshooting universes, this is going to be troubleshooting model 18 walk forward. I'm also trying to model as well, so I might throw some questions at you. Yeah, go for it. My background is economics and stats. Well, you're in the right place. Quant models, that is, and you're in the right stream to ask questions, so ask away. Okay. Okay, so now we've changed the model code. Let's save it. And let's run model 18 again to make sure that it works. What the hell? Make sure I save that. Universe is 7, test model 18's on, everything else is off. Okay, that will import the fundamental feature, and this shouldn't fail anymore. Fundamental request is still undefined. Oh no. Nothing named fundamental engine, but it's right there. Fundamental engine. Oh, L. Are you using all publicly available sources of data? Yeah, I'm actually using so I'm using the data set that's in the description. That's a really good data set. It contains all missing tickers going back to 2011. The data goes back to 2011, and all tickers that have been dropped out of the stock market are included, so you're avoiding survivorship bias. If you go to the GitHub, I have instructions for installing it there. Both of those, just the data's in the description, and the GitHub links in the description. Also in the GitHub, I'm pulling sector data, so I have a script. I think I added the script. I have a script in there for getting the sector data, and I spent basically a week writing that. Let's see, data retrieval. Get sector data. So it's not that one. Here we go. Fetch symbols. Sorry, I need to organize this. I guess I didn't add the new sector code. So let's look for data retrieval. Data retrieval, fetch symbols, get figgy info, get sectors, SIC. Okay, just a sec. It's so I have it. I just I don't know where I put it. So data retrieval, clean interest rates, fetch symbols, get figgy info. No, no, no. No, that's too small. It's like get sector data v3. Get sectors, get valid tickers, missing sectors. So I need to clean up the repository again. Pull rate data. Where is it? Well, yeah, let me find it. Fetch symbols, clean interest rates. So it's not that, not fetch symbols, right? Oh, is it fetch symbols? So we save it to symbols.feather. Okay, so in the data, it's sectors info.csv. So let's search through the code. See where is that. Because I'm saving it somewhere. I do call it in feature engine. Is it in add NAICS sectors? This is a standalone script though. Oh, it's this one. Pull sectors v3. So is this in here? Data retrieval / pull sectors v3. Oh. Okay. Script. Sorry this took so long. But this is now if I refresh, pull sectors v3. So this is the code you want. So if you go to the, okay, so there's no survivorship bias in the data because the data set's really good. The guy has good data. So go there, download it. You could also run this script to get the sector info. This also doesn't have survivorship bias because I made sure to get all delisted tickers. And if you want the North American Industrial Classification System sectors, run this script and it will add it. Everything will save in data / sectors info dot CSV. So this guy. Yeah, so let's go back to, okay, now I'm testing that model 18 is still working. So I changed the code so it will incorporate fundamental data too, but I need to make sure it's working before I do that. I've hit my rate limit. It resets in 4 hours. So I hit my rate limit before it gave me a useful answer. Very cool. I'm happy I pay for that. Let's go back to here. So this is telling me how to input. Okay, now look at fundamental engine.py. I need it to be able to perform the same transforms, i.e. d mean, CSZ score, and neutralizations, market versus sector, as feature engine .py. Update fundamental engine.py so that it does this, period. Okay, so this is running through. We'll see how it performs. Okay, I'm gonna go get another Dr. Pepper really quick. Okay, so does the model still run if I only pass it this? I mean, this is like really honestly ridiculous. All I was trying to figure out is why is walk forward analysis not working for all years, and it never gave me a good solution, and I'm paying for Claude, and it ran out of requests before it could give me a solution. Alright, so we finished running that code. Here's the feature importance. Here's the performance, and yeah, the performance is no longer good enough. Man, well, okay, that's an issue. I mean, if you look here at when I ran it last night, the performance is different. Uh, 0.0138. Now it's 0.0091. Information, although the other metrics are still good enough, but information coefficient's not good enough. Let's run it one more time to see how it performs. So I need to figure out what is happening here. Why is the performance worse? I kind of have figured that out. And why am I not getting the walk forward for all years? Here I need to see, why is the performance really changing this much run to run, or did I alter the data and it's not running well anymore? But I don't think it's the latter, but I'll run this again to see how it does. But that's it for tonight's stream. I'm kind of tired. I'm really tired. So subscribe and like the stream if you're interested. Go to the GitHub. It helps me out if you star the GitHub, watch the GitHub, and follow me on GitHub. Join the Discord. We talk about interesting stuff there. But that's it for tonight. Thanks for watching. Adios. I alter the data and it's not running well anymore, but I don't think it's the latter, but I'll run this again to see how it does. But that's it for tonight's stream. I'm kind of tired. I'm really tired. So subscribe and like the